Hello, and welcome to today's Saratech Enablement session. My name is Andrea Hall, and I'm the Customer Relationship Manager at Saratech, and I'll be your host today. Presenting today, we have Chris Kasperzak, and he is joining us from Siemens. We are so thankful that he is here, and he's going to be talking to you about NX Animation Designer. And with that, we have a little video for you, so take it away, Chris.
Hello, everyone. I hope you enjoyed that. I had fun making it, and I always have fun presenting it. Quick introduction, I'm Chris Kasperzak. I am a product manager here at Siemens. I've been with the company since about 1996, and I've had a wide variety of roles. I know you can see the webcam there, but what I looked like back in 1982, that's me with my old 1969 Mustang. That's me, that's my catfish photo right there. So whenever I put that on presentations, I usually use that, but as you can see, I'm a little older since that in 2012. All right, before I get really into this, I have a quick question for all of you. How many of you, by show of hands, there should be a little hand icon on your UI there. How many of you make products with moving parts? All right, more hands are going up. The reason I ask that is, if you make a product with moving parts, which is probably most of you on the call here, how often do you want to see them? You visualize, what do they look like when they're in their normal operation? How do things move around? How do things open? How do they close? How do you find out if things are actually going to work? Are there interference problems? Are there design issues when things are spinning around and moving? And my favorite part, which you just saw, was how do you take all that design data and turn that into a business-winning proposal for your customers? So not always about engineering, but you got to show off your designs at one point or another. And the product that we have here called Animation Designer will do just that. Here's a wide range of kinematics applications, or I should say motion applications that we offer within NX. If you're in the concept phase, which is a great place to start, you're doing what I call 2D free body diagram or stick figure design. Like a piston, for example, going up and down. You can model that very, very easily in 2D, and you can actually use Animation Designer to spin that thing around to see what your 2D sketch looks like under its normal mode of operation. Put some measurements and all that kind of good stuff. Then when you get that done, then you crank up assembly and you build your parts and build your assemblies and you do your typical assembly design type scenario. Now, do you want to see the thing move around? You probably do. That's where Animation Designer can come back in and show you how you can move things around in a time-dependent fashion. There's a sequence control on there, so you can make things happen at the right moment in time and get the right kinematic behavior, so you can do things like measure interferences and collisions and things like that. Then if you really want to see if your design is going to be strong enough, is it going to tip over? Are the motors strong enough? Are the frictions going to overcome, or the motor is going to overcome frictions and dampening factors? That's where NX Motion can come in play. Then if you want to create a fancy proposal like what I just showed you, that's where Animation Designer can come back into the story. Then if you're making machines and you want to program the PLC controllers on it, you can take all this kinematic and this motion information, bring it into Mechatronics Concept Designer, convert that into what we call event-based simulations, so where things happen not necessarily in terms of time, but when something bumps into something, you want something to happen. Like when something hits a limit switch, have the gripper pick up the part and move it around type thing. That's what Mechatronics Concept Designer is all about. And you can take all of that PLC program code, bring it back in the application, and make sure it does exactly what you wanted it to do. It's called virtual machine commissioning. All of this is all available within Siemens, the motion portfolio, and I'm really proud to present today Animation Designer. All right, so the key thing is it allows you to show your product in action based on whether it's assembly sketches, multi-body part files, discrete assemblies. Key point is it's motion regardless of the assembly structure. So if you've built your assembly, you kind of threw it together, which most people do, and you didn't really worry about motion, How do you make things move around when something is deep buried in a subassembly? Animation Designer can handle all that without having to worry about how your assembly was built. You can really create things within seconds. If you have something built in assembly, some level of intelligence, you can bring all that across. But the interface is so fast, you can really go to motion within minutes. And of course, there's a video-like editor, timeline editing tool that allows you to get the sequence of operations exactly the way you want it to. So this part opens up, then that part slides over, then this picks it up, and so on and so forth. And of course, everything is all built on a very, very fast solver, much, much faster than everything else that you've seen in the Siemens portfolio. So your results and everything else all happens in real time. So you can also optimize the digital twin. And what I mean by that is you can put some measurements on your either your free body diagram, and you can see one happening up on the screen here of a wheel type assembly, or your 3D parts, and you can measure things over time and see maximum, minimums, general trends of things. You can also use a probe tool, which you're kind of seeing in the graph here, on kind of dialing to the maximum, the minimum, or other various things on your graph to understand exactly where your key kinematic properties are. We also have an envelope command that allows you to put an envelope around the moving part, so you can do things like cover design and whatnot. You may know where the cover is in this state, but is it going to create an interference later on? That's what an envelope is perfectly designed to do. And last but not least, like I mentioned, you can plot angles, distances, motors, parameters, and all kinds of neat things on a graph and play that back to see exactly how your kinematic model is performing. Last but not least, you can explode things over time. You can fade things over time. You can change your camera over time. You can do all kinds of fun things and create really neat AVIs of your assembly in action, all while your motors are jumping up and down and your levers are going back and forth, so on and so forth, and a lot of neat color coding to help you simulate and create things much faster. This is really the first step in creating a award-winning presentation. Generally, what I recommend doing is capture a couple of view styles, maybe one with wireframe, one with shaded, then bring that into something like Adobe Premiere Elements or iMovie. Splice everything together, put some music on there, some text on there, so on and so forth. Now, I realize not a lot of engineers are in that. That might be more for your marketing department, but if you give them the raw content, they should be able to create some real business-winning proposals for you. All right, take a quick poll. Do you feel that your customer proposals are engaging? Do you think they could be better? Do you think you could snazzy thing up and maybe win more business if you had a much better story to tell? Show of hands, raise your hand on the icon on the screen there. This is the one thing that people tend to not think about when it comes to engineering is turning into some fancy, flashy stuff like we're going to, like we just saw a minute ago. But you can do that with Animation Designer. All right, with that, I'm going to stop PowerPointy stuffy, and I'm going to get into actual NX and show you the product in action. So what we have here is just a basic machine here. I think there might be 100 components in here, nothing, not too complicated, but fairly well detailed. What we want to do is we want to see what this thing looks like on its normal operation. Then we want to find if there's any interferences. And then we're going to create this really, really cool animation out of this thing here. So let me expand my navigator here, and you can see all of the parts that we have in our assembly here. And while it's a very small, subtle thing, here is the problem. These little components here that I'm highlighting in red should have been part of this other sliding mechanism, so when it goes back and forth, these guys come along for the ride, but they're not. They're going to stay fixed to this other part down here. This orange component that I have highlighted, I want these parts to be all part of it. Now, I don't know where they are in the subassembly, and I don't care where they are in the subassemblies. I'm just going to move them the way that I want to move them. All right, so what Animation Designer does is it allows you to define what can move, how it's going to move, and how fast it's going to move. How you define things, how move, is something called a rigid group. So up here on our Animation Designer tab here, I've got a new group, contacts, we've got relations, so you can kind of make joints and stuff between things. You can add motors, my favorite play button right here, and a bunch of other fun things that you can mess around with. All right, so what we're going to do is I'm going to change my option up here to a rigid group color. So anything in a color is defined as being a rigid group, like a big block of stuff that's going to move around on the screen. So what we're going to do is I'm going to create a rigid group out of this component, this one, and maybe that one right there. Again, I don't know where they are in the subassemblies, and I really could care less. All I want to do is make sure these things all move together. Then I'm going to draw a rectangle around everything. I want all of these components, maybe this little motor and There might be some nuts and bolts in the back of here. Try to get all of these things and all these little extra components. I want everything to go along for the ride here. That's probably going to be good enough. So we'll apply that. Now I want to grab all of these components from my navigator here. And these two little slider mechanisms down here, remember that was the problem I identified earlier. They're in the wrong subassembly, but I don't care. I'm just going to make them go with that green part right there. And last but not least, let's get all of this kind of what I'm going to call this frame mechanism here. We'll make that all a rigid group. And maybe just a couple more. Let's get the this rotator head. And oops, wrong one. Let me add, I forgot to add this part here, the small rotating part to my rigid group, otherwise it has nothing to rotate about. Then we're going to add these components right here to a rigid group, and this little pincher, I'll call it a pincher, and this other pincher, and that will be good enough for all of our rigid groups. Now you can do a quick visual inspection here. If it's in a color, it can move. If it's not, it is not going to move. It's going to stay on the screen for you. So this is a nice visual way of seeing exactly what you've got in your model. Step one is done. Step two is how can things move? Well, what I'm going to do is I'm going to use a concept called a joint. And it's kind of like an assembly relationship, but a lot more powerful. You can have a fixed relationship, a revolute, which is rotating stuff around, something and slides back and forth. Cylindrical slides and rotates, the infamous ball valve here, and several others that we have. My favorite thing, lock it down first. Then I'm going to slide all of this stuff back and forth with a slider joint. I want this to slide along this, along that vector. And I want this blue part to slide along the green part. I'll call it a green part, even though it's a rigid group, along that vector. I want this plunger thingy to go up and down along that blue part, along that vector. And a couple more, I want this part to rotate around. So I'm going to change my option to a revolute joint, and I want this guy to rotate about that green part around that axis. And if I can control my mouse here, one last one. I think we'll do a, let's do something for the grippers here so they can slide in and out. So this gripper is going to go back and forth, and I want the positive X to be in that direction. And one last one, and we'll have this gripper go in the other direction here, so it can pinch something as it picks it up. All right, now step two is done. Now, if this were defined in assembly with any level of intelligence, we would bring a lot of that intelligence across and create all of these joints automatically here. This assembly wasn't built very well, so it doesn't lend itself to that. That's why I went the manual route to do the rigid groups here. All right, let's do a quick analysis to see where we're at. There's a command up here that allows me to move things around and gives me the idea, if I've got things generally in the right fashion, those little slider mechanisms are moving back and forth with the green part like what I wanted. This part's moving up and down, and the blue part's moving back and forth. All right, that's one way that you can see generally if you've got your joint set up right. My personal favorite is something called this joint jogger up here. What this allows you to do is sort of articulate one joint at a time. Maybe you want to show your machine in this fashion with the gripper here, rotate it a certain distance, plunge down, so on and so forth. You can do that, and you can remember that setting so you can always do your door open, door closed scenario with a flick of a button. So let me just create one more, and I'm just going to pick some random things here. This may not make a whole lot of sense, but you'll get the idea in just a minute. And now we cache these joint joggers, so if I want to click one, there's door open and there's door closed, or there's machine up, machine down, that type of thing. All right, now part two is done. I'm very confident that I've got my joints in the right spot. Now let's make things happen automatically. You've got a couple options with Animation Designer. You can use a position motor, which is like an intermittent motor, goes to point A to point B and stops. You can track that back. A speed motor is like a fan, runs continuously. I can measure all of these things, put these motors on there, or I'm going to use something called inverse kinematics to give me everything automatically. So I'm going to move my gripper from this part here in the center point of that gripper. And I know I would be a little more gingerly with my picks here if this were a production run here. And I'm going to go to this end over here and rotate the gripper around maybe to 90 degrees. Hit the OK button. And before I can find the fit button, it has generated the motors for me automatically. So all I need to do is hit the play button, and it articulates all of that motion for me. I've got all these things happening all at one time. The only thing that it didn't do is it didn't apply 2 motors to my sliding joints here. Actually, it added the motors, but it didn't add the right value. So all I'm going to do is go in here and hit 30 for the distance, hit OK for that one, and this other one down here, I'm going to hit, sorry, wrong motor, 30 for this one right here. Doesn't always get every single motor the distance defined correctly, but you'll see those little pinchers pinch in there. All right, now step 2 is done. Now I want to actually control when things are going to happen. So here's where this little timeline comes into play. Expand my window just a little bit, and we have all of these motors on here. Another color option here, as you would imagine here, there's a motor color. So my blue motor is represented by the blue bar, my salmon color motor is represented by the salmon color bar, and so on and so forth. So if I move my cursor back and forth, I can see how everything is all articulating. And I actually think I've got my gripper motors going in the reverse direction, but that'll be good enough right now. All right, now it's all a matter of when do you want things to happen. So for example, I want this thing to articulate maybe the blue motor and the salmon color motor to go for about 3 seconds. So I'm going to increase the length of those bars to about 3 seconds. Then I want the thing to rotate around. Then I want the plunger to plunge. That's the green one. You can just see by the color coding. And then I want the blue, what was that, turquoise motor and yellow motor to kind of pinch. So these could be the last operations that we do. I'm just going to drag these bars around. And now you'll change the sequence of operations to give you a much more refined look of your assembly and how it's going to really operate in motion. Now, as I mentioned, I've got my grippers going the wrong direction, but that's okay for right now. All right, you can of course pan your cursor around. You can right-click on something, you can split it to add a dwell. You have all kinds of neat control over all of your events here. So if you don't like that, you can move things around. You can drag these bars. Maybe you want to have a bit of a delay in the beginning. You can play with this thing all day long. The key thing about this part of the demo here is it's all happening in real time. As soon as I hit the play button, we compute the transforms and we spit the answer out immediately for you. So if you want to do something like mirror, my favorite, select everything and we're going to mirror it. And now it gives you an exact mirror, but what we don't want is we don't want the pinchers to pinch right after it pinched. We want it to release after the fact. So I'm just going to reverse a few events here. And you'll see the slider come over and across. Then it will rotate, then it will plunge, then it will pinch, and it will retract, return, go back to its original spot here, and then unpinch. And there you go. Now we have a really good sequence of operations here. And of course, if you didn't like that, you want to move things around, you can also grab these events here, move things around, and kind of have all kinds of fun with when things happen and so on and so forth. So that's kind of a timeline control built into Animation Designer. It lets you really control the sequence of operations. That's the whole point of this, is make your animation and your product look exactly the way it's going to operate. Question number 2 is now answered. Now we know what this thing looks like. Question number 3 is, do we have any interferences here? So I'm going to turn on collision detection, and if there's an interference, it will turn on red. We do have an option here to pause on collision, and another one for what we call lightweight or precise solving mode. So right now we're using a blazing fast solver. So as I hit the play button, it's doing a interference check at every single point in time during the animation here. I have a bunch of them on here. A couple I knew about. I'm not really going to worry about the motor and the gripper there. There's probably just something sticking out here. And there's one at the very end where I had this thing plunging way too deep in the model here. I don't really care about that one. This is the one of my concern right here. I've got something actually in the track of my assembly here. Now, just visual inspection, you could have found that one here, but if it was something around the back of the model or some small part, you probably would never have found that. So what we're going to do is we're going to fix that in front of your very eyes. So to validate the fix, what I'm going to do is I'm going to measure it first, fix it, and then measure it later on. So we've got this cool tool up here that allows you to measure distance between faces of moving objects. When I graph these things, it's going to show me what the actual distance is between those two faces as the assembly is going through its animation. Anywhere there's a 0 distance, you've got a collision. So we have a couple of them there on the upstroke and the backstroke. So all I need to do is simply toggle my cursor to wherever I want. Go ahead and probing mode here. And I can dance my cursor back to kind of right where that interference is. So what I'm going to do is real quickly go into my component and fix this modeling or this model. So we're going to make this my work part, and I'm going to go into some good old-fashioned synchronous technology here. I'm going to grab that face and move it out of the way. Now, normally you would put some dimensions on here. You might do some wave linking to make sure this thing is exactly the right distance that you need. But I'm just going to pull it and tug it out of the way for now. It's probably going to be good enough. So let's go back to our top level assembly and turn my graph on, and we're going to play this motion again and see if I have that interference fixed. Now, where the parts were colliding, they're not colliding, and I've got a 40 millimeter gap between the two. I'm not going to make a decision whether that's the right distance or not. Personally, I think it's fine, so I'm going to kind of move on. We can do this wherever we want on our assembly here to see what the distances are between moving parts, which I think is a handy thing. Can you imagine trying to figure out where the displacement is between a valve and the piston, not at top dead center, but somewhere along the way? Very, very tough to do, but with Animation Designer, the motor here, it's quite easy to do. All right, that is number 3. Question number 3 is answered. Now what I want to do is let's turn this into some fancy, fun kind of a thing. So I'm going to change my color option once again, collision detection off, to explode color. And what this is going to let me do is explode things over time, and anything in a color will be actually exploding. So it might be cool to have the frame explode apart, then maybe the table drop down, and so on and so forth. Imagine if there were cases around this thing or cases around your product, which it probably already has. You could peel back the layers of the onion to see the core. So how that works is I am going to pick these frame components here, and I'm not going to be real gingerly about my selections here. I'm just going to get stuff in the path here, what I think is close enough and good enough. I'm not going to worry about getting all the little nuts and bolts. I want this thing to explode off into maybe the left. And notice it turns blue. Lets me know that that is now going to explode over time. And let's get these little baby feet here and these little caps here. And I'm going to explode this thing, you guessed it, to the right, some distance. And I'm going to pull the stuff off in the front here, and I'm going to pull that to the front. And pull stuff off at the back here and make that go to the back. And that's probably good enough for right now. Now we have a 1 second default duration on here. If I would have turned an option on, if I drag my mouse very slowly, it would track time based off that. But now we have this thing exploding apart while the machine's doing its magical thing here. If I don't like that duration, I can of course drag these things, make them a little longer, move them around. So not only is this for creating really cool, flashy animations for customer proposals, you could use this for assembly or disassembly. So let me just play with this for a second more, get everything in the right spot here. Then we'll move on to the next explode type operation here. So the way I recommend working with it is put your cursor where you want an operation to have, maybe here, and let's explode this table up and out of the way. Let's grab this table and a bunch of components, and we'll explode this maybe over and then down. And then we'll move our cursor over a little bit further. Maybe after this table is done, we'll explode it. Maybe we'll explode it this way, then we'll rotate it around. And then we'll drop it straight down. And that's probably good enough for right now. Now we played our animation, you'll see that not only is the machine doing its normal operation here, but things are exploding, maybe accentuating something very, very critical of your machine. And in my world here, it's the gripper. We're the only company that will knows how to pinch parts. So I want my customer knowing that there's the pinching mechanism that you're going to give us tons of money for, so let's make sure they can see that live. All right, now that we've got this thing exploding, and I get to play with these events and move them around to get the right duration and change their event duration and stuff like that. Now might be a good time to hide things over time. So what we're going to do, I'm going to change our color option again to, you don't have to do this, but it's my personal favorite way of working. I want everything to kind of start disappearing. So I'm going to go to my animated visibility, and I'm going to grab this entire frame here, this little guy, and we will change my navigator here so you can see it. Changes visibility, so it's going to start going invisible as it explodes. Then maybe around here, I want this whole table here to go invisible. So we'll pick the whole thing, and give it a little bit longer duration. And then maybe around here, we'll have the table top go invisible, and we'll have a long duration there. And maybe somewhere around when this thing is articulating back, we'll start to hide the mechanisms. Now, this might not make a whole lot of sense to hide that entire rigid group there, but it'll be fun to kind of see it disappear and have the whole kind of mechanism here do its magical hide routine. One last thing here, I'll pick that rigid group. I think we'll call it a day. That will probably be good enough. So let me turn all my colors off, hide my timeline, hit the play button. And just like that, not only is this thing going to explode, but things are going to disappear, all while the gripper's moving in the right location. It's pinching something and doing whatever it needs to do. But wait, there's more. What would be really neat to do is if I can see this thing in different orientations as time is going on. So I'm going to make my timeline really small because the only thing I care about is this little time marker right here. That's going to allow me to change my point of view over time. Let's turn perspective on. Let's look at the model in this perspective. Let's remember that camera at that point in time. Let's dance our cursor over to about this spot here. And let's zoom in a little bit because I want my customer looking at the gripper head. I'm going to remember that camera at that point in time. And then maybe as it's dancing back, let's rotate it around so I can see the full travel of this thing. Maybe remember the camera at that point in time. And maybe at the very end, maybe just kind of pan over a little bit. All right, now what the software is going to do is going to interpolate between all of these keyframe settings here, change my my walk around of the camera while it's exploding, while it's fading, while the camera or the gripper head's dancing up and down and doing all of its magic. That's the first step. Now, what I would recommend doing is when it's done rendering here, export this to your favorite movie format. And I would recommend the H.264, your favorite resolution, the frames rate, and all that kind of jazz. Save that off to an AVI file, then bringing that into a post processor like Adobe Premiere Elements or iMovie or something like that and create a really, really cool, snazzy presentation. If you don't want to do that, that's what your marketing department can help you out with. But the key thing here is you now have the tools to create assembly, disassembly kind of instructions for maybe some live online utilities and things like that. All right, with that, some notable takeaways that if you have a product that has moving parts, this is a great way to visualize motion before you start doing some detailed design. Before you put all your nuts and your bolts, your washers in there, before you detail your parts out with rounds and all that kind of jazz, you might want to see what your motion looks like before you go that far. With this tool, could you get up to 92% savings over physical prototypes? Yeah, maybe. Depends on how many you make, depends on what they cost, but just a real simple study. If it cost you a few $1,000s to build a prototype, takes some time to test it, takes some time to put it all back together, fix things and test it again, you could probably do it a whole lot faster with the animated digital twin. And last but not least, if you're in the business of selling products, which everybody is, you probably want to razzle and dazzle your customers. This is a great way to do it. Thank you very much, and hope you enjoyed what you saw.